if 2 to the 3x times 4 to the y is equal to 64, and 27 to the power of x times 1 over 3 to the 2y is equal to 9 to the 6, solve for x and y. So what we've got to do is we've got two equations here. We've got to find x and y that satisfy both. So this is simultaneous equations, but in a bit of an unusual format. So we've got 2 to the 3x times 4 to the y is equal to 64. Now the secret is that 2, 4 and 64 are all powers of 2. So we should rewrite these as all powers of 2. So that's going to be, the first one will be 2 to the 3x. 4 is 2 squared, so it becomes 2 squared to the power of y. And 64 is 2 to the 6. That now means we have 2 to the 3x. Now we know from the rules of indices that a to the m to the n is a to the m times n, so this becomes just 2 to the 2y is equal to 2 to the 6. Now using this rule of indices, that a to the m times a to the n is equal to a to the m plus n on this side of the equation, it's going to give 2 to the 3x plus 2y is equal to 2 to the 6. Now we have the same base on both sides of the equation, so for the base to be the same, that will mean that the power of 3x plus 2y has to be equal to 6. And we're going to call that equation 1. Right, we'll now take the second equation, which is 27 to the power of x times 1 over 3 to the 2y is 9 to the 6. And this time we'll realise that 27, 3 and 9 are all powers of 3. So 27 is 3 cubed to the power of x. Now 1 over a to the n can be written as a to the minus n, so we're going to rewrite this one as 3 to the minus 2y. And then 9 is 3 squared, so we'll just write that as 3 squared to the power of 6. So that gives me 3 to the 3x using this rule here. This one will keep the same. And then using this rule here again, this rule here, that will become 3 to the 12. Let's write that out again. Right. Now use a to the m times a to the n is a to the m plus n. That means that 3x minus 2y, so 3 to the 3x minus 2y must be equal to 3 to the 12. Again, we have the same base, that means the powers have to be equal. That means that 3x minus 2y must be equal to 12. Now we have two equations. Now we have, simultaneously, 3x plus 2y is equal to 6, and then 3x minus 2y is equal to 12. We can do that by adding. So if we add, you see these would be eliminated. So you get 3x plus 3x, which is 6x. Nothing from here. 6 plus 12 is 18. X will be equal to 3. If we now substitute into equation 1, we're going to get 3 times 3 plus 2y is equal to 6. 9, 2 3 3s are 9, plus 2y is equal to 6. 2y will be equal to minus 3, and therefore y will be minus 3 over 2. So therefore we have the solutions that x must be equal to 3, and y is equal to minus 3 over 2. Now we don't have to do the next bit, but it would be good to just check in the original equations that these actually work. So we're going to have 2 to the 3 times 3 times 4 to the minus 3 over 2. So this becomes 2 to the 9. The minus means, right, this is 1 over. The 2 will mean take the square root of 4 and then cube it. 2 to the 9 is 512. Square root of 4 is 2. 2 cubed is 8. So this becomes times 1/8. 512 times 1/8 gives me 64, which is what was on the right-hand side of the first equation in the question. Going to the second equation, so we've got 27 cubed times 1 over 3 times 2y, so it's going to be 3 to the power of 2 times minus 3 over 2. You're going to get 27 cubed this will become 1 over 3 to the minus 3 because the 2's will cancel out. 27 cubed times 3 to the 3, when you deal with that one, the negative index will make it go to the top. Okay, and then you're going to get 3 to the 9, because 27 is 3 cubed. 3 cubed is 3 to the power of 9 times 3 to the cubed, which is 3 to the 12. Now you could write that as 3 squared to the power of 6. I've still got the power of 12 there, which means I get 9 to the 6, which is what was given at the end of the second equation. Okay, so the answers are x is equal to 3 or y is equal to minus 3 over 2. So there's been a video to show you how to form linear simultaneous equations using the rules of indices and then solve them. I hope you've understood, and I thank you very much for watching.